Welcome. As our final example of horizontal asymptotes and limits at plus or minus infinity for rational functions, we are now going to be looking at case 3, where the degrees are the same. Okay? So, a graph has a horizontal asymptote. So what happens in this particular circumstance is that the graph has a horizontal asymptote, so the I'm going to do this in green. So the graph has a horizontal asymptote, right? And this horizontal asymptote is going to be y equals the ratio of the leading coefficients. And we're going to have to kind of talk about what we mean by that. So of the leading coefficients. Okay. And so what do we mean by the leading coefficients? What we're talking about, so by a leading coefficient, what we mean is the coefficient in front of the largest power term. So this is the coefficient in front of the largest power term. So coefficient in front of the largest power term. And we'll see an example. The largest powered term. So the term with the largest power, we look at, so we look for the largest power, and then we look at the coefficient in front of like x. So if it's x cubed is a large, right, is the largest we have, then we're looking at the coefficient in front of x cubed. Okay, so let's look at an example. And in this example, we're looking at f of x equals, and we're going to have 2x plus 1, sorry, 2x squared plus 1 divided by 1 minus 3x squared. Okay. And then looking at the degrees, right, so this is degree 2, so this has degree equals 2. And then this is the highest power, is a 2, because the power here is 0. So this is the highest power, and there's the leading coefficient. It happens to also be 2, that's okay. So my leading coefficient is also 2. So there we have, right, we have degree 2, right, coming from this, and coefficient 2 coming from that. Okay, and so leading coefficient is also going to equal 2. Great. On the bottom, again, my highest power has to be the same. So my highest power is, again, 2. So the degree equals 2, right? Because we're in case 2, so the degrees are the same. So we are indeed in that case, right? Because this is 2, again, the degree on this one is actually 0, because it's like there's a little hidden x to the 0 there. Okay, and my leading coefficient then is going to come from in front of that. So my leading coefficient is 3. So my leading coefficient is going to equal 3. Great. So now let's go ahead and draw this. So I have x like this, and I have y like this, and then I have the graph of my function. So I have, right, so this is going to kind of go like this, and then like this, and this. So kind of highlight what's going on here. You should actually see, right, so here's my asymptote at y, right, at minus 2/3. Oh, this is a minus 3. I screwed that up. Right, we got to catch that there's a minus sign in front, so this is actually a minus 3. Good thing we caught that. Okay, so this is minus 2/3. And this is the graph of my function. So this is the graph of y equals 2x squared plus 1 divided by 1 minus 3x squared. Again, the same degree. So we're taking the ratio of the leading coefficients, which is the 2 and the minus 3. And that gave us this as my horizontal asymptote of y equals minus 2/3. Okay, and we also remember that this is our x is going to infinity. This is our x is going to minus infinity. And we can see that as I go towards infinity, what's happening. So what's happening with this limit? So what I'm getting is at the limit as x approaches infinity, so as I go infinitely far right, what's happening is I'm getting that as I take the limit of this, my p of x over q of x, which is this function, right? My rational function, then I'm getting out minus 2/3, which was the ratio of the leading coefficients, right? And that's why I got that as a horizontal asymptote. And I get the same thing as I go in the other direction, right? As I go in this direction, again, I'm seeing the limit as, I'm going infinitely far left, so I'm talking about a limit as x goes to minus infinity of, again, my function, which I'm purposely rewriting as p of x divided by q of x so that you remember that that's what I mean up there, okay? And we're getting, right, so what happens is I go out there, again, I'm approaching minus 2/3. Okay. So that's how I end up with that particular horizontal asymptote. So the tricky part about this one, it's nice the degrees are the same, you just have to look for the highest power term on the front, on the top, and the highest power term on the bottom. You look at what's in front of them, right? In this case, it's 2 and minus 3. And then that ratio, so minus 2, or 2 over minus 3, which is minus 2/3, is actually going to give you your horizontal asymptote. You can kind of see as I go out towards infinity, I'm approaching this, and the same thing as I go out towards minus infinity. You will get the same thing with these rational functions. Okay, so I hope that made some sense, and I will see you in the next lecture.